Welcome to the deep dive. Today, as you're preparing for those senior software engineer technical interviews, and really for anyone building distributed systems, we're diving into a really key decision. Picking the right data serialization format for communication between services. These choices, they really matter. And understanding the trade-offs is, well, critical for showing you know your stuff architecturally.
Absolutely. And what's interesting as you look at different tech is how much control you actually get over this. Some, like gRPC, often come with protocol buffers sort of baked right in, making the choice for you in a way.
Right.
But then others, maybe like Kafka, give you a much wider range of formats to choose from. So our goal today is to dig into these formats, look at their, pros and cons, and give you the insights to make decisions which will definitely look good in those interviews.
Okay, let's start with what's probably most familiar, textual formats. Think about the APIs you use every day, especially RESTful ones. Text is pretty much the standard there.
That's right. And within text formats, JSON has really taken over, hasn't it? It's interesting to think about why that happened, especially since XML used to be everywhere.
Yeah, it really feels like JSON became the default. The big part of that, I suspect, is how well it plays with the browser. JSON and JavaScript, they just work together so easily. Plus, there was this perception, wasn't there, that JSON was just simpler, more lightweight than XML.
That feeling of simplicity and being less verbose was definitely a big push. Its direct mapping to JavaScript objects made parsing in browsers super fast, which is a huge win for web apps.
Definitely.
But it's important to remember, especially when you're thinking about network traffic, that the actual size difference between, say, a compressed JSON file and a compressed XML file, it's often not as massive as people sometimes assume. Compression is pretty smart these days.
That's a really key point, yeah. Especially for interviews. Don't just assume JSON is always way smaller. And, that initial simplicity of JSON, it came at a cost, didn't it? Like schema validation wasn't really a big thing early on.
Exactly. The focus was more on getting things built quickly. And that sort of paved the way for formats like Avro. What's useful about Avro, especially for messaging systems, is how it takes that JSON-like structure but adds a crucial schema layer.
Okay.
And often the schema can even travel with the data payload. This really helps with managing different data versions and making sure services can still talk to each other as things change, super important in distributed systems.
So Avro kind of tries to give you the best of both worlds. Familiar JSON structure, but with that added safety net of a schema. But it's interesting, even with JSON being so popular, there are still valid arguments for XML in some places.
Oh, absolutely. You'll still find strong XML supporters, and their points often center on the mature tooling. For instance, if you need to pull out very specific bits of data from a big, complex document, XML has things like XPath, even CSS selectors, which web devs know well. The tools around these are really well established.
Right. XPath is powerful, whereas with JSON, we have JSON path, as you said, but it feels like it's not quite as universally adopted or maybe as feature-rich.
Yeah, the support and ecosystem aren't quite on the same level. It shows that sometimes the format that looks simplest up front might have trade-offs when it comes to the tools you need later.
Makes sense.
And it's also kind of funny to see how features that were sort of natural in XML, like high-time media controls those links within the data, helping clients find related things. People are now trying to bolt those onto JSON APIs, sometimes a bit awkwardly.
Yeah, adios and JSON can feel a bit forced sometimes.
It does make you wonder if maybe some useful aspects of XML got thrown out a bit too quickly in the rush to JSON.
Definitely food for thought when designing APIs.
I think it is.
Okay, so that covers the human readable side. Now let's shift gears. What about when raw efficiency, payload size, processing speed is the absolute top priority? Let's talk binary formats.
Yes, this is where things get critical for performance. When you're counting milliseconds or trying to minimize bandwidth, binary serialization becomes really attractive. And in this space, protocol buffers are a major player. They're tightly linked with gRPC, obviously, but people use them way beyond that too.
Protobufs, yeah. They seem like the go-to for many teams needing that performance boost. But they aren't the only option in the binary world, are they?
Not at all. There's actually a whole ecosystem. You'll see names like simple binary encoding or SBE, Cap'n Proto, flat buffers. Each one is designed with slightly different performance goals or trade-offs in mind, often targeting very specific use cases.
Right. I remember you mentioning benchmarks before. It's easy to see a chart showing one format is fastest, but you warned against just taking that at face value. Why is that so important?
Because those general benchmarks often don't mirror your specific data or your application's behavior, how your data is structured, how often you read versus write, your network conditions, all these things massively impact real-world performance.
Okay.
If you're in a situation where you need ultra-low latency, the only real way to know what's best is to test them yourself with your data in your environment. Don't just trust a generic benchmark.
That makes total sense. What works in a lab might not hold up in production chaos. And you also made a really practical point earlier. Sometimes focusing only on the serialization format isn't the biggest win.
Exactly. For a lot of systems, maybe even most systems, you might get much bigger performance improvements by looking at more fundamental things like, are you sending too much data? Can you reduce the number of network calls altogether?
Right. Optimize the bigger picture first.
Yeah. Sometimes those higher level changes dwarf any micro optimizations you'd get from switching serialization formats. It's about perspective, especially when answering business questions in an interview.
So pulling this together, especially for someone prepping for senior interviews or just designing a system,
Yeah.
what are the absolute core things to weigh up when choosing a format?
Okay, I'd boil down to a few key factors. First, readability. Do humans need to easily read and debug this data? If yes, text formats like JSON or maybe even XML have a clear edge.
Mhm.
Second, interoperability. How many different types of systems, languages, platforms need to work with this data? Standardized formats, again like JSON or protobuf, usually have broader library support.
Okay.
Then, obviously, payload size and processing efficiency. If performance is paramount, that's where binary formats usually shine. You need to weigh these against each other for your specific needs.
And the crucial thing, especially for interviews, is there's no single right answer, is there? It's always about the context.
Precisely. The best choice depends entirely on the specific requirements and constraints of the system you're building or discussing. Being able to explain why you'd choose one over the other in a given situation, articulating those trade-offs that shows real system design understanding.
Yeah, that demonstrates the depth they're looking for at that senior level.
Absolutely. It's that analytical thinking they value.
So yeah, picking a serialization format isn't just some minor detail. It's a real architectural decision. It impacts performance, how easy the system is to maintain, even how painful debugging is. It definitely warrants careful thought, both in design and when you're talking through scenarios and interviews.
Couldn't agree more. And for everyone listening who is prepping for interviews, really spend time thinking about these trade-offs. Practice explaining the reasoning. Why choose JSON here? Why protobuf there? What if requirements changed? Think about systems you've worked on, or even hypothetical ones.
Yeah, definitely. And maybe a final thought to leave everyone with. Picture a distributed system, maybe one you built or just one you understand.
Yeah.
How would changing the serialization format potentially affect its behavior, its performance under stress? How easy would it be to track down bugs? What factors in that specific system would push you towards one format over another? Mulling over concrete examples like that really helps solidify these ideas.